Morning everyone, and welcome to the 2017 Redhead Combine and Header Clinic. My name is Paul Steiner. I'm with MacDon, or MacDon as I quite often say. I'm out of the Winnipeg office. I'm the marketing product specialist, and I work and support all our sales and marketing people on the product. I come from the service side originally, and prior to that I used to farm. So I've kind of got the farm boy roots and kind of know, I like to think, some of that common sense. That can be debatable some days. But what we're going to do today is we're going to talk about this 2017 MacDon header for you. Show you some of the features, some of the benefits, and we're going to talk about some of the service points. Some things that you may or may not know, some tips and some tricks and that kind of stuff. Talk about information and where it is, because in this day and age everything is about information and getting your hands on the information. And what we want to show you is that information is available to you multiple places, be it through manuals, through handouts that you all have, through websites. It's the information is there. It's a tool. Just know that it's there, and then know that you can use that, and that can help make life a whole lot easier, much more efficient, and more efficient means more money in your pocket at the end of the day too. What we have is basically the same as what we've always had, is the two products. We have the adapter and we have the combine head. Remember that they're two different products, two different machines. So when you're looking for help or looking for information, there's going to be two different parts catalogs. There's going to be one for a header and there's going to be one for the adapter. If you're looking for a sickle section or a guard, if you're in the adapter book, it's not going to be there, right? It kind of makes sense, but sometimes it's one of those things, you're looking at the book, it's not in here. Oh, I got the wrong dang book, okay? Talk about the books. Everybody know where the operator's manual is? Parts catalogs, the quick card? I want to see lots of heads moving here because we've all been in there and we've opened them, right? Yeah, okay. Behind this end panel right here, okay? And we'll come around to that in just a little bit. But remember that is there. Every header comes with an operator's manual. Every header comes with a parts catalog. And there's also a quick card in there showing field adjustments and quick settings. And that stuff on the quick card is going to be things that we expect that you can do, that you can know how to do. We'll find once we go through here too, it's a lot of complicated mechanism and it looks kind of scary, but really we'll break it down. It's really simple. We have separate functions for each, two adjustments for each. It's all laid out in a quick card and it's really pretty simple. I think the first time you have a head, you look at it, you look at this linkage, you look at the two pieces, you look, what is going on here? It is a complicated beast, but when you get down, you break it down and you see how they function, it really makes it a lot simple. And if you have that basic understanding, then you can help yourself in the field if you see something not working correctly. Okay, so we remember we have two components. We have the adapter, which is our drive supply, if you will. It mounts directly to the combine. Okay, it has an oil reservoir, which is running in the leg on each side in the top tube, right along here. And that's our oil reservoir for our hydraulic system. On our hydraulic system, we drive our sickle and our belts. All the real functions come from the combine. Come through the multi-coupler that you plug in. So reel lift, reel fore aft, reel drive, all from the combine. The sickle comes from us, and the drapers come from us, hydraulically. And then we have a chain in our gearbox, which we'll get to in a minute, which drives our drum. So our drum is the only thing that's mechanically driven on here. The thing I like about a hydraulically driven knife and drapers and systems is that allows us to easily put relief into the system. If you get to a spot in the field that's tough cutting, heaven forbid you're driving along and you hit a T-post, okay, that sickle will stall. It'll just go over relief. You won't see anything other than it'll quit moving. You might be able to feel a bump probably too, right? Okay? But you're not going to have any shafts whipping, and you're not going to have anything else going. It's just that quick. It stops, the pressure spikes, it goes over relief, everything shuts down for you right there. Knock off your kill switch and go find out what it was. A horseshoe, a T-post, a cultivator shovel. Okay. We don't have slip clutches or nothing for that needs to be adjusted. Okay, that's the beauty of hydraulics. It's right now, it's instant, and it's relief, and everything is off. So in our reservoir right here, it's about 60 liters is what it is, and it's 1540 motor oil. So that's what we run as a hydraulic quote-unquote system. There is a decal right beside the oil fill plug, and if you read the fine print down at the bottom of it, it does say 1540 motor oil. So remember, keep that. If you happen to have a failure and you lose a bunch of oil and you top it up with hydraulic oil, we're probably going to see some loss of functionality. We'll probably get some foaming. We might generate some more heat. You'll see some loss in productivity. So try and keep it as 1540. Okay, and it also says it in the operator's manual too. Okay. Being that we have a hydraulic system too, we have a filter that is in behind this cover. We've taken the cover off, and the hydraulic filter is right here. So we recommend changing that filter at 50 hours. That's just a break-in. There'll be a couple other things we talk about at 50-hour break-in, but that being one of them. Then we're at 250 hours after that, or basically seasonally after that. Okay.
And that's the filter that's in that kit too. That
exactly the kit that Curtis showed you right there, the proper combine one, FD75 one, does have that filter in it as well. I will say one caveat too: if you have an older machine, if you have a 2013 or 14 or something, it is a different hydraulic block on there, so the filter is going to be different. Make sure you look in the parts catalog that came with your book, or look in the parts catalog if you're online. See if there's either a serial number break or a year break or something. That'll help you to make sure you do get the right parts. So difference being actually between the older and the current is the sealing O-ring. One is a round O-ring, the other is a square cut O-ring. So if you take off the filter and you see this O-ring and it's a square cut and the one in your bag has a round, just make a phone call and swap it out. Just remember that, because if you try to put the wrong one on there, it's not going to seal for you. Okay? So also, like I said, we have our oil supply, we have our source, we have a suction line. It comes through to our pumps. We have a pump stack right here. First off, we take our drive from our combine. It comes into this gearbox. We have gear-to-gear mesh to our knife drive pump is our first big pump on there. And that is going to be set for a knife speed depending on your combine, depending on the jack shaft of the combine. Okay? The service techs, when they're setting them up at PDI, they do check that to make sure that it's set where it needs to be, and they make it right. Okay? It is swash plate adjustable, and then it's also pressure compensated for relief. Piggybacked on the inboard side of that is another little pump. It's a gear pump, and that is that supplies our side drapers and our center drapers. So they're running in parallel, if you will. The two pumps are driven the same, take different supply and different pressure, and they pressurize different systems. So oil comes from that second pump, our gear pump. It goes out to our center draper first, then it comes back into our block and goes out to our side drapers. And then if you have a cross auger, like this one has, then it goes to the cross auger as well. Then back to filter and tank. Also inside this gear case, I mentioned we have our drum, which is mechanically driven, so there is a sprocket and a chain that runs up to the top, and then that is direct drive over to our drum. That being said, there is a slip clutch that is in this gearbox, so if we do contact or we happen to ingest an unharvestable object, that we do have relief on that drum. It will come around on a rock or whatever it is, and it will stop, it will slip for you. Okay? And one last thing to point out right here too, is we do have this knob, okay, and that is our draper speed knob. This is how we control our side of the speed of our side drapers, and by that also our cross auger. Typically what we'll do is, it's a detent position, and we'll put it at about click 5. So close it all the way up, and click, click, click 5, which is pretty much on the bottom, or at the 6 o'clock position. And that's for most crops that we're going to run, typically lentils, wheat, barley. If you do a lot of straight cut canola, you might find you want to jack that right all the way open, make it all the way fast. That just helps with the feeding, get that light bulky crop, get it going quicker to the middle. And that's one of those things that we find you don't need to be adjusting that as you go through the day or through the field. Basically you put it on 5 or in the middle there for your cereals, and then open it right up for your canolas. Okay? That's pretty much all it is right here. Okay? We'll start walking our way around right here, like I say, and if we just want to keep on moving, we'll end up all the way back on the other side of the combine. Coming around to our header end panel right here, we open it up. And right now that's as far as it opens. But if you're getting in to check your belt tension, or if you want to check your oil level in your wobble box, that's probably all we need. If not, you need more. There is a castle nut right here that you can take it off, and then the whole cover just comes right off. So if you have to do any work in here, if you're coming to get your spare sickles out, now you can pull them out easy enough. On double knives, until 2013 when we come with the 5 series, the FD75, On a double knife, we could not put the spare sickle in because we had too many lines. The hydraulic lines for our reel were running in here, and we didn't have the room. We've since then moved the lines outside. The steel lines are outside now. That gave us the room, so now on a single knife or a double knife, both spare sickles are going to be in here on the left-hand end. That's a really good option. Again, you can only get it when you're ordering, or as the salesman call it, configuring a header, but remember to ask for it because you're going to get the full width sickle in there. If you have to replace it from parts, it's like everything else these days, shipping is a problem, so it's going to come in about 7 to 8 foot segments, and now you have to build it up. Curtis mentioned that lickety-split knife kit. That's what you do. You lay down your segments, put on these splice kits, and away you go. Okay. So our hydraulic oil comes from our pump, comes from our motor right on the back side here, and then that takes our drive through our drive pulley and belt down to our wobble box. The wobble box is a MacDon designed wobble box. It's the same one we've been running for quite a few years. It's been working really well for us. It is oil bath as well, 85-140 oil in there, and it's right around that 2 quarts as well. Exact numbers, again, can be found right here. Everyone knows what this is, right? Everyone has been inside this little black box, just like an airplane. All the important information is in that little black box, and it's right here. Parts catalogs, operator's manual, and the quick card, okay? I know this is an operator's manual, but sometimes the information can actually come quicker from the book here, so remember it's there. One little trick I'll tell you too, I like to visit customers when they're in the field in season and see how things are going. We've had issues or we didn't have issues, things are good. But I'll always open up this panel and I'll just have a look right at this box. We zip tie them so they stay closed for shipping. Okay? If that zip tie is still there, we'll have a talk, okay? I can't stress enough that the information is there. If you happen to lose the book, you took it and you left it in the washroom in the house, right? That's where you're doing all your reading. You left it there. Now you're in the field. You have trouble, okay? You got a smartphone. If you have cell service, you can go to www.macdon.com. There'll be a tab that says Product Support. You click that tab and there'll be a little drop-down menu, and that will have all the parts catalogs and the operator's manuals for this head and all of our equipment as well. So back to right here. We talked the wobble box, 85-140, okay? We want to change that oil after 50 hours, the break-in period, and then again, it's 3 years every 1,000 hours after that. The maintenance schedule is in the operator's manual. So I've talked about 3 things already that we need to do at 50 hours. What were they? Filter, gearbox oil, and the oil right here in the wobble box. Perfect. Right on. Okay. Drive belt. The drive belt tension. Important to keep that belt tight. Okay, it's like any drive belt, you don't want to slip the belt. Once you slip it, you glaze it, now you lose your traction. Okay, we're designed to run this really tight. In the book, again, it will tell you it's 20 foot-pounds of deflection, and I think it's 1/2 to 3/4 of an inch deflection is what it is with 20 foot-pounds of force is what you want to look at for tension. Again, don't quote me on the numbers. I don't want to give you numbers because I want you to have a look in that book. It's in there. So we're coming up and we're grabbing the belt and we're pulling with what we think is 20 foot-pounds, or you can get gauges as well. That will do that. We'll measure that torque. And that deflection is what we want for proper tension. If the belt is too loose, what's going to happen? Yeah, slip, glaze, burn, smoke, and now next time you get to some tough cutting, no good. On the wobble box, we do have the dipstick right here. So it is a dipstick for your oil level, okay? We want to have it kind of just at your cutting height, just on the ground, just off the ground, kind of somewhere, you know, in this space, because your wobble box is pretty level. That's what we're looking for. It also is a breather. So if we overfill it, let's be careful. Maybe take some oil out. If not, it will get warm and it will blow it out through the breather holes. When you get back home, if you've got a head that's a year or 2 old, just have a look, make sure it's in this rearward position. Part of PDI, these guys here are awesome. They do a good job, but one of the things we do is we tell them to move from shipping. It's actually in the forward hole. And that's because these headers are shipped up on their back and the oil is in them. So with the breather holes, if we had it in this lower hole, most of the oil would run out by the time they sit in their yard or come out in the truck here. So proper operating is having this in the rear hole. We have a couple of things to check right here too. We like you to check these 2 bolts. on the side and 2 bolts on the bottom. Those are the wobble box mounting bolts. 200 foot-pounds is what we're asking. And I would say after the first day of running, if you have a torque wrench, put it on there and just click, check 200 foot-pounds. Do that once, twice, and now it's kind of a once-a-year thing. You may need a crow's foot on the bottom. There is one bolt that you can stroke your belt to move your pitman arm, move your knife head out of the way. If you can't quite get it, maybe if you got a little crow's foot attachment, you can get it, and that's good enough to make the torque. I'm going to show you 2 of the most important decals that we have on this header. Okay. One is right here, 25 hours, and that's for our knife head. The book says 1 to 2 pumps every 25 hours. That's it. Do not overgrease. This is one spot overgreasing is going to hurt you. We basically have a hydraulic seal in there is what it is. And if you start overgreasing, we're filling it up, we're actually putting pressure on that whole knife head. Put too much in, we're actually pushing that knife head down. So that stroke, 1,200 plus times a minute, that sickle is coming in and out. When it comes out, that pressure pushes it down. Now when it's stroking in, it has to go back up to get on the run and back out. Up, down, up, down. If you overgrease that, you can break your sickle about that far in, just past the knife head. Old dust cap cover grease zerks right on the knife that you used to grease, the grease come out, right? That's good. And then a little extra just because. And do that twice a day, right? If you're cutting long hours. No, those guys are the ones that have problems because they didn't check the book, right? Okay. If you do happen to overgrease it, no big deal. Just take a little wrench, back the grease zerk out. Oil will, or the grease will just come out. Has anyone had to replace a sickle drive belt? You did, yeah? How was that? Bit of a bear? Bit of trouble, or was it? Yeah?
We had to really loosen up and kind of pry a bit on that top pulley to get it changed.
To get it down? Okay. Also, if you have to, because the pulley for the wobble box is on the inboard side, I don't want you to have to take the wobble box off to get the belt under there. There's not enough room to slide it through, or it's very, very tight. There's an access panel right on the inboard side of this head here. Okay? Yeah, it might take a few minutes of swearing, but yeah. Or you grab the book, right? Okay. Swearing's easier, yeah. So there is a panel here, one little bolt, that panel comes off. Now you can feed the belt through. Before you do though, just feel your hands around the inside flange of that pulley, the inside flange. There's going to be a knockout or a place where that pulley is actually machined back, probably about an inch wide. And that's just to help you. Now you can rotate that pulley into the place where your knife belt is coming through. That gives you just that extra little bit of room. That's going to make it a lot easier for you. Okay? Now, right here, we're getting to the business end. We're getting to the part that this is where we can start to make or lose money, our sickle. I'm not going to tell you how long sickle can last or how long it should last. But what I will tell you, if you take care of it and know what's going on here, it will last you longer than if you don't. Some guys we see, used to work on the custom harvest run, supporting our custom cutters in the US. Guys that did daily maintenance on their sickle will get twice the hours or twice the acres that guys that just ran. And at, what's the price of a guard now? 15 or 18 guards, or 15 or 18 bucks-ish? 25, whatever it is, you know. You times that by the length of the head. I don't think it's 25, come on now.
It's actually more.
Okay. So whatever the price is, you times that by the number of guards you can have in a 40-foot header, that's going to cost you a lot of money. If you can double your wear on them, that's saving you money, right? Okay. The first thing for the wear we look at is our hold downs. Right here. The hold down is exactly doing that. It's on top of the sickle section to hold it down. Hold the sickle to the bottom part of the guard. That bottom part of the guard is where our cutting surface is. That's our shear point. You've probably heard it before too. It's like a pair of scissors, right? A pair of scissors is loose. They won't cut. They'll switch. They'll swish around to pull the paper in between. That same thing happens right here too. Okay, we're talking 20 thou clearance on there. If you get wider than that, now especially when you get into tough cutting, it's going to pull that grass into the guard and tear it instead of cutting it clean. So that creates more wear a lot sooner, also creates higher operating pressures, and increases the operating temperature. All things we don't want to have, right? Plus costing you money. Simply adjusted, 9/16 wrench, and just turn on the bolt and just tip it over. I will tell you, if you've been out in the field for a few weeks, or even say second season, rust, dirt, crap gets in there, they seize up, you can still do it the old-fashioned way with a hammer, just there's a right way and a wrong way. So we have our cup of our hold down. Where do I want to hit it? I want to hit it on top to drive it down. I want to come in the front, exactly. If I hit it on top, I'm actually mushrooming it open or flattening it out, so we're actually getting wider. So if you do come with a hammer method, come with a punch, hit it on the front. Tap, tap. If you get a little too tight, well, now just hit it on the head and it'll open up for you. Simple as that. Okay. Every day. Check them every day. What else are you going to do in the morning, right? Is there any other daily maintenance on this header? Is there any daily maintenance on a combine now? Really, there's not. You blow the filters out when they tell you. You put fuel in, really is about it, right? So there's not a lot. So if you come and you take 5 or 10 minutes and just walk along, whether you use a business card, okay, or if you have a 20 thou feeler gauge, whatever it is, and check, it'll take that long. A couple of adjustments. You only have to do a few. But if you don't do it, you do it once a year. Now you got a lot of them to do, and you'll find that now I probably got to replace guards. I got some broken sickle sections. I just got a whole lot more work that I got to do now. Okay, it's one of those I can promise you will make you money. Keep talking about guards. Double knife. How many different types of guards do we have in this header? 3, 4, 5. I got a $5 bid. $5 bill, give me 6. This is a double knife, so we have 5. If you want to get technical, you can say 6 by part numbers. Okay. The reason I say that, our overlap, our center guard is actually 2 separate part numbers, one top, one bottom. I call them one guard. So that's 1. Have our very outside left, 118301 part number. That's kind of a half guard, if you will. The first half, the first tip is right under the divider cone here. So that's like this. Then we have 118302. That's the very outside right one. That's the same thing but opposite. The first half guard is just, or first half point is just under the divider. Then we have our, there we go. Yeah, thank you, sir. We have props that we forgot about. Look at that. 118301. This is going to sit right under our divider cone here. 118302. So this piece sits under there. Also does not have a ledger plate. That's key. From our very first guard, the next 3 are 118345s. These guards. They also don't have that ledger plate right here. This is the ledger I'm talking about right here. Okay? So technically it's the first 4 guards from every knife head. Don't have that ledger plate. Exact same over there. Then the rest of the guards are 118345 with this ledger plate. What does not having that ledger plate do for us? What does it allow? It allows movement, exactly. Because if you look at the way our sickle is driven, it's not a piston running straight in and out, it's on an arc. So all the way out, that sickle is back. As it comes half stroke, now it's moved forward. All the way in, it's back. So it's doing that. 4 1/2, 4 1/2. What we want that to do is we want to give it that foot of room just to settle into the run. What would happen if I broke a guard here and I didn't have one, I just had one of these in the middle and I put it on? What would happen? You're going to have vibration that you didn't have. So hopefully you'll see, as soon as you fire it up, you'll see this thing start. Something's wrong. You might even hear a bit of a tick, 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 tick. Yeah, if we don't change it, you'll end up breaking your knife about that far in, just past the knife head. So there's 2 things that would be, I would say, a high 90s percentage of the problem for breaking a sickle, especially just at the knife drive end, and that's overgreasing and the wrong guard. And then right here too, we just have our top and bottom pieces of our overlap. Okay. One question we get asked quite a bit at clinics on our service line, I have a double knife and I want to get rid of it. I want to make it a single knife. Or I want to turn my single knife into a double knife. No, we can't. And the reason, if you want to look at these guards, I'll leave them out here for you. You'll see that actually our sickle is running on two different planes. Our left one is actually going to come over top of our right one, okay? And so the way the guard bar is welded to it, it actually has to be lower. So that's part of the problem, plus mounting restrictions and all kinds of stuff. So just a short answer, we can't do it. And this tells you right here, because it's about a 3 mil difference in the running plane of our sickle. We've come to our center section now. Our center belt of our adapter and the center section of our reel, or the center area. A couple things we want to point out to you. First, about the drum, the fingers. On machines that have some hours on them, you see there is a plastic guide that the finger runs through every time it comes in and out. Make sure that guide is in good shape. And good shape is what I'm talking about, is actually the size of the hole. That finger can sometimes deflect or wear on that poly or that plastic, and if it does, if that hole gets too big, if you did break that finger, it can now come out. You've all been inside the drum one time or another for something or other probably. The finger is in a holder with a R-clip, and then you'll see there's a roll pin through the bottom of that finger. The idea being for that roll pin is so it cannot come out through the drum. So we keep those plastic guides in good shape, and then it cannot. If you can take off the access panel, take out a couple R-clips, and you pull your finger all the way through, it's time to replace them. Okay, keep that in mind. Drum height adjustment. While we're talking about the drum, we have the height of the drum to the pan, or to the feed pan, the stainless steel feed pan. Okay, we do have some settings or some guides in the book that we want to set it at. They come pretty good from factory. The guys at PDI here check to make sure. Probably looking about 3/4 of an inch. Okay, and what we're going to do is we're going to check it. You're going to actually put your tilt cylinder all the way forward, and then obviously your header has to be in the combine to do that, right? Lift your header just off the ground like this is, crawl underneath and have a look and see what that dimension is. On either side of the drum then, if you go out to the ends, you'll see there's a draw bolt on top. Just follow that a little bit lower, and there's going to be 2 clamp bolts on either side. Loosen the clamp, turn on the draw, and you can raise it up or lower it as you need. If you're going to get into some serious heavy canola, you might want to lift it up a little bit. Okay, but always put your header all the way out. Tilt it all the way forward. As we go back and forth on our tilt, what actually happens, just like my arm here, if you will, it pivots at the back, and all the way out, that feed deck is just, or the feed pan is just a little bit higher. You suck it all the way back, it actually drops away. So we want to measure it at the tightest point, so that if throughout the day you're adjusting, you don't get it too tight and now start rubbing. Drum extra finger holes. There's the drum comes, I think it's 17 fingers, and there's 20, I believe it's 25 extra holders in there. You can, in conditions or crops, particularly canola, add extra fingers. So you have to take off the blank off plate, get the guide, bolt that in, and then put your finger in. There are extra holders in there. So what I would say too, if you're going to put extra fingers in, stand back where you are and look. Don't put fingers outside the actual opening of your combine, of the feeder house. Okay? So the design, the intent of a finger on a drum is to take that crop and throw it off the drum, throw it back. The flighting is working to bring it to the middle, the fingers are throwing it off. So if you put fingers outside the opening of your feeder house, now you're throwing it back to that dead spot back there. And now that's the first start of trouble feeding. So yeah, stand back here and look, only put extra fingers to the width of your opening. Center belt is right in front there, obviously. Tensioning is get from the bottom. We can show you that later if you like, if everybody's seen it so we know what we're looking for. Again, it's in the book. It shows it's in the book. I will say one thing though too, that is spring loaded, so it's always moving. It's always keeping it under tension. It's usually pretty good. If though we have issues with center belt stalling, again depending on crop conditions or the crop you're harvesting, I would have a look right up front here. We all see this flap that's over top of the center belt. Okay, we put that on to help with seed loss, particularly in soybeans is where we found it, but we also do find it sometimes in really, really dry peas, sometimes maybe in lentils. When you come to the end of the field, come to the end of the row, and you pick up, and there's no more crop coming in front, that belt would flip around and there'd be some material sitting there, and they'd see beans going off the front. So we thought, well, what can we do to prevent that? Well, let's put a flap there so the beans don't stay there. In some conditions, we can see a buildup of material underneath here. And then that might slow the belt or stall the belt. That's the first place I look if your center belt is stalling, is that jam full of material. So we have two options. We can drop the pan on the bottom and clean it out, or we can take that flap off. Some guys say they like to cut it back a bit. I would prefer to take it off because now you can put it on or off as the conditions or as the crop changes is what you need. I have also seen in straight cut canola, especially when you get a sprayer track, right kind of in this area here of a couple of feet, that canola is kinked over a little shorter, usually drier. It'll come in and it'll just kind of do a little dance. It'll just sit here, just kind of spin, and that'll start of a lump. We've also found that can kind of hang up on that poly there as well, or that rubber. So if we take that off for a condition like that, then that'll just keep better feeding or help with your feeding.
Is it hard to take off?
It's 5 bolts.
Okay.
Yeah. Lift your header up, put your safety prop on, drop your gray belly pan under there, and then take them off. Yeah. Yeah. It's not that bad. Nothing is ever easy, right? But it's not that difficult. So.
Well, it makes more sense than cutting your belt back.
That's what I would think. Yeah. Yeah. Now you have it. If you like it off, you can keep it off. If you want to put it back on for whatever reason, away you go. You're fine. The buildup where it come with the belt is under the plate here. If we put that here, and we did have that actually back in 2008 or 9, we had a steel plate. But what we found, kind of by just trial and error, this actually is a heck of a rock sump.
It is.
Catches a lot of rocks.
Yep. Big ones.
Yeah, yeah. So if we covered it, which we did, we covered it. It was a full metal plate that went in there. Now those rocks, they had nowhere to go but all the way through. So there is a kit that we have. It is a rock retarder kit. Basically, it bolts to your guard bolts, and it just sets up a little ridge. Oh, what is it? Maybe 2 inches?
Yeah,
About 2 inches, just a straight wall. And then it's like a little piece of angled tin. Just so it's a straight wall that if you do get a rock, and it'll stop baseball size and smaller, maybe softball size and smaller rocks, and just leave them set on your cutter bar instead of scooping them up, if you have rocks.
It slows them down so they fall into the well, like don't go up in there.
They're not getting flipped all the way up higher. Yeah, yeah. They have to, right. They just kind of flip over. Now they're at the bottom, and then they get dumped into the sump. Yeah.
Does that bar reduce your feeding capability?
If you're in some really, really short crop, you can see a reduction in feeding. Yeah, yeah. But now you got to tell me where you want to pick your poison, right? So, yeah. But yes, it can, in some really short crop, it can cause some issues. Okay. Actually, before the reel, one thing to point out, the cross auger. Okay, in the center there are grease zerks. I think the book says 250 hours. Okay, I'll probably get hell for saying it. But on that slide where the left slides into the right, probably grease that every day. Okay, because it's a hex bore shaft that's sliding into each other. As your wing moves, even if you're not using the P auger, but we're on the ground, we're cutting lentils or something, that is still moving. So we want that to be able to slide. If that does seize up, well, now one of your wings or both wings may not move to their full maximum that they can. Okay. Oh, we rolled it around. Okay. Right here, we can see where the notches are. If you find that the one grease zerk is a little tight to get to, don't worry about having to Dremel it out just a little bit wider, because the one's on a bit of an angle. You can get it, but sometimes it's a bit of a battle. Just Dremel it out a little longer to give you more room to come in for it. Up in the center here, this is our reel drive. So there is a chain in here as well as a universal to drive our 2 reels. Okay, there are grease points on there as well. And it is a chain, so check the tension on machines that you've got some hours on, some acres on, a season or so. Look at that chain tension. There's going to be 6 bolts you're going to see there. We're only going to need 4. We loosen it up, and then basically we're prying on the motor then to lift it up to tension the chain. Not the sweetest design, but it's not something we have to go after every day either. Just remember it's there. You check it once a year, you probably should be good. How many people have got material in between their belts, installed their belts last year? Now last year, I guess, if anything was going to happen last year, it was going to happen last year, right? Okay. But one thing we want to look at, we can limit the amount of material that gets in between those belts. And where we look at that is, we call it our deck seal. So that's the relationship of our belt. Our belt actually, if this is our C shape of our cutter bar, our belt actually runs underneath. So we have a deck that belt runs on, and we can raise or lower that deck to change that gap. Okay, basically we're talking about like a credit card thickness in there, a millimeter or so. From brand new, we like it just a little bit wider until we get a little bit of dust and dirt on that belt. The belt loses its tackiness, and then it just runs smoother. A little bit of baby powder on there too. But we're looking for a millimeter of gap. So we have, depending on the size of your header, you'll have 4 or 5, we call them hangers or hanger brackets, and they're going to be bolted to the deck that the belt runs on, and then it's kind of a little, like a J hook or a C hook, if you will. It comes back up and it's going to set on top of a angle iron that's welded inside the cutter bar. And this is all shown in the operator's manual. Deck height adjustment. We'll show you right now how quick and easy it is to do. Well, relatively speaking, right? So I want to get inside there. I need to see that. What have I got to do? Loosen the draper tension, right? So it's on the back side. Maybe if Joe wants to loosen it for me. And we'll come around there and we'll point that out to you in a minute, or if you want to go have a look right now. 15/16 wrench. And just back it off. We'll just give this idler pulley a kick. Just push it inboard, and you'll see the slack come up. Can you get under there with your foot? There you go. Now we can see all the slack we have. Come to your connector link, or your connector slats. And just then peel your belt up. If you want to have a look there, you can see how that is underneath. So we need to have that fairly snug. So we lift it all the way up. If you want to split your belt completely, go ahead. Can I get that 15 from you? Thanks. Just take your wrench, a stake, whatever you want, prop that belt up. And now we come in and we look and we find our hangers. So there's one here. There's going to be one on either side of the hinge point, so 2 right there. Another one about here. And the last one's going to be right here. So we go in and we look. If you want to go have a look, have a look. So we have that, it's like a cast piece is what it is. 2 bolts are going to go through to the actual deck that the draper runs on. It's going to be right here. You can see it right here.
Oh, yeah.
Yeah. The trick for raising it, okay, is again not to loosen off those the bolts too much, a couple of flats, okay? But before we do that, I guess what I should say, you got the Allen key right there. Thank you, sir. Take an Allen key, a piece of key stock, something that's the thickness of this edge, okay, the thickness of the belt, and add a millimeter. If it's 3/8 or 5/16, it's 7 mils, 8 mils, 9 mils, whatever it is, find that. Use that now as your guide. We set that on the deck, and we just try and slide it underneath the cutter bar. If you slide it underneath and you can wobble it around, that tells me then, right, that's why I'm getting material in there. I need to raise that up. So keep it, use it as a guide, keep it in there. Loosen off your 2 bolts. Take your punch, put it on the cast piece that's right there. Give it a couple of raps with your hammer. Good sharp raps. And the concussion will just lift that deck up. We're hammering on the cast piece and we're just giving it a shock. And it's just spreading this much, and the natural movement wants to come up. Yeah.
So should all of them be loose at the same time?
Do one at a time.
Okay.
Yeah, one at a time. And you can do it just like this. Loosen off your tension like we did, kick the roller in, a wrench, whatever, come and do this one, move over to this one. You know, it gets a little tight in the ends, but you can do it. If you want to open it right up, open it right up. Your call. Okay? If we keep that snug, that 1 mil, I'm not going to say you're never going to get material in there, because you're probably still gonna, because we still have a millimeter gap. Cutter bar might not be exactly dead straight, so there's going to be opportunity, but we're going to limit it. When you're in dry conditions, once a day or so maybe, if you happen to be filling up with the grain cart or the truck instead of going down the field, just sit there with your header all the way up and let it run, because the belt is going out on the bottom, so it'll take all that material. If you have the header all the way up, there's just a little area where that stuff will jiggle out, and you'll put a lot of material out the back. If we get into conditions like we had last year, all bets are off. We can limit it as much as we can, make it as snug as we can. We can't go too high though. If we go too high, that actually belt will deflect, and you actually will probably hurt yourself even more. Or we can make it so tight that maybe that belt stops running, or runs hot, right? So you know, it's one of these things. We want to kind of get it in the best possible spot without going too far. Okay. Any questions on that? Y'all can come back later and we can show you too if you want to have a good look at it. That's fine. Okay. Continue this side right here being a double knife now. There's going to be a wobble box and a pitman arm and special guards and the belt and all that kind of stuff. The same thing is going to be on this side as it was on the left-hand side. Okay. Right here now we're at the reel. I'll get Joe to point out our cam for our reel pitch.
Right, and here's our reel pitch, or our cam for a reel pitch. And there's 4 different settings, and you can see them here on the side. They're numbered 1 to 4. Your quick card, they'll tell you which setting you'll want for which crop condition.
Yep, roughly, yep. And what we're doing when we change our pitch of our fingers, we're not changing the way the fingers come into the crop. We're changing the way they release the crop on the back side. And the reason we do that is because on down crop, you got crop that's all blown down by a big old storm, or you got that amazing wheat crop, right, so heavy it falls right to the ground, okay? You need to send the reel out in front to get after it, to get it to pick it up so you can cut it. So in our normal position for canola was probably 1, wheat would be 2, you know, and then if we got down crop, you can go to 3 or 4. In the normal position or a canola position, the fingers are in the crop and out of it really quick. So when your reel is back over top of your cutter bar, kind of mid-span, if you look on this right-hand reel arm sitting in the combine seat, you can see that there's numbers on there, 1 to 9. And about 5 is about kind of mid-span, which puts this tube kind of just in front of the cutter bar. And we want the fingers in the crop just to kind of grab the crop or cup it, hold it till we cut it, and then knock it on the head to fall in the belt. We don't want it to thrash. Okay? So standing wheat or canola, we want it in and out, and we want it to knock it on the head and away it goes. But when we put the reel farther out, we need those fingers to actually carry that crop farther back before they let go of it. If your reel is all the way out and you have your fingers in the crop, they've already let go of it before the reel or the cutter bar even gets there to cut it off. So we can send the reel all the way out, change your pitch now to 4, and the fingers will come in, grab it, and will carry it farther back before they drop it, and now they'll drop it on the belt. Simple as that spring-loaded pin, we back it out, a 3/4 inch wrench. Okay, and we can just turn the cam by hand, just like we're doing, and we see what we're changing the fingers. So if we come to the end and look, you look at the front, we look at this reel, it's a dual reel, so there's the same in the center. We didn't change anything here, very little change here, but we have more change at the back. So that's kind of what I want to show you. Go and have a look. Look all the way down the end and you can see that the fingers on this left-hand side, they've already let go of the crop. And this side here, the fingers are still aggressive, still holding the crop. They haven't let them on the belt. Pretty much the same down here. Yeah. So this one no, this one a little bit, that one lots, right? It's awesome. This right here is what makes the header, the way this reel functions. Okay? The way we can set and change this pitch of the reel and make the fingers work. The way we can set the reel height like you were talking about. Okay? So we have the guys at PDI, they check the height, and we want about a 1/2 inch clearance. They have a special procedure how we check it. It's in the operator's manual. Take 6 or 8 inch blocks, put them just inside our hinge point, make sure our float is unlocked, set the reel all the way down, and that brings the reel the closest point at that hinge point. Go measure. Put your reel about halfway out, rotate your reel so the cutter bar or the finger's just over top, and measure that gap. We set that to about a 1/2 inch. We'll never customize these fingers. You shouldn't. If I see fingers customized on a MacDon, I get cranky because something's not done right is what it was. So if we need to adjust that, or if you add, say, that rock retarder kit, because that does change that height a little bit. We have 3 cylinders. Okay, we just go right to the cylinder, and on the 2 outside ones, there's a clamp bolt, and we just turn on the clevis basically, turn the cylinder around, and it backs out, raises it up. In the center, if you look, a little bit awkward with the cross auger, but just underneath there, if you look at that center cylinder where it's mounted, where the pin goes through, you'll see it's on a slide. So there's a draw bolt or a push bolt that we just move it fore and aft on that slide, and that will either raise or lower that reel in the center. Okay, so yeah, that's a very good point. If you do add a rock retarder kit, you need to check to make sure that you're not going to be clipping on these things all day long when you go right down. I do want to point out one thing right here. I pointed out this side because there is no decal, so now you got to think about it. On the left-hand side there is a decal, but it's going to talk about Draper tension. And Draper tension, we're looking right in this little, it's about a 1-inch slot right here. We see that little white indicator bar. Correct tension for operating is when that white indicator is on the inboard half of that slot. Where is that white indicator right now? It's on the outboard half. So if I didn't even go around to the front, if I'm coming up here in the pickup truck and I'm looking, I can tell right now that this belt is not tensioned. Maybe that's why you're slipping, right? So all we do 15/16 right on here, turn it clockwise, tightens it up. And what will happen actually is that white indicator will actually come back this way. There, like I say, there is a decal on the left-hand side. It tells you exactly that. I don't know why we put it on both, but one's good enough, right? Okay. If you go to check your Draper tension with the 9/16" wrench, wrong wrench. Some guys do get on here. No. That is for our tracking. So what we're doing with there is actually we're pushing the back end of our roller outboard or bringing it inboard. So that roller now is running not true or off true, however you want. So that belt runs true. Guys at the factory do an awesome job at that. We don't. The only time we really have to go here, most cases, because somebody was in there before us. Didn't look at the decal or didn't look in the manual. This is what makes our header work. This is what makes us different from everybody else. It's mechanical, coil spring, and this linkage. This, for new customers, this is what you look at and you think, oh, there's a whole lot of stuff going on here. I don't know what's going on. Sometimes you got to trust the engineers. And I tell you what, these guys, they're some smart guys. They did a heck of a good job on that. I don't know how it works scientifically to explain it. I just know it works, right? So we have 2 functions. We have flotation. That's the vertical movement of the whole header, up and down. And that's through our coil springs. These 2 here. We have 2 on either side. 2 on the left side, 2 on the right side. They're pairs. We adjust them in pairs. We work them in pairs. Stretch them in pairs the same amount. And that's about 7 inches of vertical movement up and down. Then we have our wing, which is on this balance linkage right here, connected to a shaft that runs down here, which is connected to our float linkage on the bottom. And that's how our wing moves off of our center section. We have the right side, and then we have the left side. So we have the wings, each wing is independent of the other and independent of the center section. So for our float, we need to unlock our float. That's what this is. It's our lock. It locks it out. Anytime we're going down the road transporting, if you're at one end of the field a mile away and screaming across the field to get to the other end, get out and just lock that up. That's limiting the amount of movement. That's cutting down that 7 inches of vertical movement. That's knocking it down to about 1 inch or maybe less. We don't want this head doing this. It's sticking out in front of the combine. You're going down the road, you get that head moving, and all of a sudden you can get out, you can get all cattywampus, as my friends say. Anytime the separator's engaged, that handle is down. And there's a handle on both the left and the right hand side. If you're just going to cut wheat, that's all we need. Put that down. When you're going to cut in the ground, cutting peas or lentils, that spring lock does our wing. This linkage in here will drop down, and now this wing is moving independently of the center section. So for checking our float, we keep our wings locked. I want a rigid header. I want a solid cutter bar all the way across. In the quick card, that's in the manual storage case over there on the left-hand side. I believe in that handout you all have there too, we talk about this as well, setting float. There's a bunch of pre-adjustments that we go through. Do them first. If you're setting float, setting wing balance, checking something, you're unsure of something, something's not right, somebody got a wrench and screwed up something, start from the beginning. Start from that front page of that quick card. And it talks about pre-adjustments. Pre-adjustments are just this. Obviously hook the header up to the combine. No brainer, but right, that's part of it. We cannot set float when this is on its transport. We cannot set float or wing balance or anything when this is sitting on a header cart. We can't. It needs to be on a combine. Make sure you're on level ground. Might need to check your tire pressure. Lateral tilt. Make sure that's level. What I like to do is take a little level, 8-inch level, and just put it on top of this back tube here. Just make sure. Sometimes if the lateral tilt hasn't been calibrated, you could tell, no, it's telling me straight, but it ain't straight, right? Okay, so we want everything level. Level ground, level feeder house, good tires, all that kind of good stuff. Then we're going to tell you to make sure your wheels are in the up position, because we want everything off the ground as we're going to check stuff now, because we're going to be lifting and moving stuff. We don't want any ground contact at all. If you have the gauge wheels or the transport, slow speed transport, lift them up. We're going to tell you to unlock the float, because we're checking that, so that makes sense. We need to have it unlocked. We're going to tell you set your cutter bar down about 6 to 10 inches off the ground. Put your center link tilted out to B1/2 in the middle. We're going to tell you to put your reel all the way down and push it halfway out. Some of us can see on that reel arm like I talked about, there are numbers on there. When you're sitting in the combine cab, look out the window, and we're going to look just right past this shield right here. When we see the number 5 come, close enough. So those are our pre-adjustments. They're stated on that quick card. Do them all. Don't set your header in the field when you're sitting like this. You can set it, it'll work well as long as you drive that way, but what happens when you go the other way? Now you're going to have trouble, right? So don't cheat yourself. Doesn't take long. Do that, we take our wrench and we put it on the bolt head right here. Okay? And then we just push down. And we're going to look at this reading. And I want to see the highest number. Try and do it a solid, steady stroke. If you load it up and go back and forth, see that number changing, it's always going to be different. Just a nice steady stroke all the way down, and look at the highest number you get. That was about a 2, I think. In that quick card, in the top right hand of the first page, there's going to be a little chart. It's going to tell you, do I have a 30 or 35 foot header, a 40 or a 45? Do I want to cut on the ground, or do I want to cut off the ground? Go into that box. And it will tell you between, I want to be for this size of header, I want to be between 2 and 2.5. So if you're not, if I want to be 2.5 and I'm at 4, what does that tell me? I'm really struggling to push this down. It's too heavy. It tells me that's too heavy. So then what I got to do, I take the big bolts and I turn them into the springs. Turning them the bolts in stretches the springs, makes it lighter, just like an old haybind. So if you're going to do them before you start adjusting, just kind of come and have a little visual. Just kind of lean down, look. Make sure they're about the same amount of threads in each one. Tape measure, that's fine. Make sure that these two are the same and start from there. Now I make adjustment, turn on my bolts. I do say 4 or 5 turns. Do that to the next one. So we keep this pair working together. Then check it. I went the wrong way, made it heavier. Well, okay, just go the other way, right? Whichever way it is. When you get to your number, good. Then go over to the other side and do it on the other side. But what I will say, don't look at the threads from this side to the other side. The amount of threads shown on those bolts are going to be different. Just I work the 2 on the left side the same. The 2 on the right side are the same, but they're different. Whatever they are, they are. You have a wobble box on one end, you have this said part of transport is heavier, all kinds of different things we're taking up for. every time you add or take off weight, we're affecting how this works. Especially going to affect our wing balance. Last year we had conditions that were just absolutely horrible. That end here was getting all full up with mud on the skid shoes and all that kind of stuff. 15 or 20 pounds of mud can make a difference in how that thing's going to perform. We got to check that periodically when you're in bad conditions like that. Even to the fact that those skid shoes, you can take them off if you want, if they're just sitting there collecting dirt. Okay? When we're cutting right on the ground, we want to be running on the cutter bar poly. So those,
you can just take them off and leave them off, the outside ones?
the outside ones, yeah. Yeah. If you want to leave a stubble though, and you want to run, now you'll need to put them back on.
Yeah.
But yeah, if you're in conditions like we had last fall, that's just going to be a catch-all for mud and stuff sitting on top of there. Yeah. I'd take off the skid shoe and then I'd also take off the mounting bracket, 2 big bolts. Take that off. Yeah. Okay. So we've done both sides. Our float is set. We're to the number. What I would say is whatever that range is, set it to the lighter side of the range. Don't go on the heavier side. Just to work a little bit better.
So it says like 2 to 2.5.
Put it to 2. Yep. Yeah, don't go any more than 2. Yep. Okay. So that's our header float. It's that vertical movement. We can adjust it so light that you can go out there with 2 fingers and lift that head up. Hard to believe, 8,000 pounds right here, just under. And you can, with 2 fingers, you can lift that thing up like nothing. That's awesome for wet conditions, but you might never keep it on the ground. Your forward momentum is just going to keep that thing up. So that's what we're doing, is finding a happy spot. With this right here, it's something that I can give the wrench to anybody here and we can all come very, very close. The old way, they used to tell you to turn your coil springs, go out and lift it. And now everybody's 50 or 75 or 200 pounds is different. Now here we just use the wrench. It's a coarse adjustment, but it's made to get us close. It's like horseshoes and hand grenades. If we get this thing close, it's going to work real well, right? Yeah, what happens when you're right on the ground and you're pushing it down, the amount of weight or whatever it takes, the force it takes to lift is the force it requires to push it off the ground. If you keep that matted down, showing my age, who's all played tiddlywinks? Okay, so what do you do with that? You push it back, right? You push that little thing back and it pops forward. Well, the same thing is happening with that cutter bar poly on the ground. It's going over the ground and stuff, if you watch it, it's spitting stuff up. And that's getting up onto the backside of that little poly plate or the skid shoes or the cutter bar, and eventually it vibrates and works its way in and gets picked up by the belt. So yeah, that's absolutely the way to do it. Make it a little bit lighter, and now as long as you can cut, as long as you're not skipping crop or missing everything, then you're fine, yeah. Not to mention you get longer life on your poly then too. Okay. So one last thing I want to show you, I think, and then we can be open up to any kind of questions we want, is wing balance. This is kind of where people really get scared and really get concerned and stuff starts happening. But all we're doing is balancing this wing. If you have a look, it's what's under here, this bell crank, this compression link which runs down. If we look, this compression link is on a slide, okay? So if you think of that compression link as your pivot point, your center point, your teeter-totter, we move it outboard or inboard, changes the way that wing is going to move. So we take our wing, or take our wrench, sorry, unlock our wing, put our wrench on, and we just pull down and look at our number. Look at our reading down, go up, look at our reading. And the book, what it's going to tell you in the quick card is the number going up and down should only be half a number out. If I go all the way up and it's 2, I come down, it should be 1.5 or 2 or 2.5. Should be somewhere close. If we can get it close, within one number. And if we can't, if it's not, okay, there's a jam nut or a clamp bolt on this clevis, this cast clevis. Loosen that off, and then we turn on the end of our draw bolt. And all we're doing is we're just pushing. We're moving that clevis or we're moving that pivot point inboard or outboard. So I have my float set at 1.5, what it's supposed to be, like the book says. Seems to be fine. I'm going along the field. I'm not pushing dirt. I'm not really skipping over anything, my whole header. But one wing kind of seems to, just this wing, kind of seems to be going along. And if I hit a bump or a little swale, it kind of goes up. Takes a little while to come down. Just this one wing. What does that tell me about that one wing? It's too light. So I have my pivot point and my adjustment. Which way do I adjust it to make it just a little bit heavier? I want to go inboard. Makes it heavier. That's all we're doing, moving our pivot point. If this wing is just scraping the ground, is leveling it, and you see no stubble because it's just dirt, just this wing tells me this wing is too heavy. So if that's the case, I move my pivot point which way? I move it outboard a little bit. And that effectively is going to make that wing light. That's the magic right there. It's not, first time I saw one of these, I thought, oh boy, I don't know that I can do this job. This is too much for me. I'm just a farm kid. I don't know this. I'm not a mechanic. But when I had it explained to me, and we're talking just balance for the wing, that's all it is. Finding that sweet spot. That's all it is. What I will tell you, you can use this wrench in the yard and get her real close. Let the field, let the stubble, let the ground tell you what needs to be done for the wing. Use the wrench for put your float to the number, awesome. Let the stubble tell you. If you're seeing it skip one wing, left or right, it doesn't matter. That's a balance thing. Just go that and adjust it. And what I'll do is I'll make a mark in the dust with my finger. I'm not smart enough to know which way I got to turn it to move it this way or the other. I'll just turn it. Am I moving it the right way? Awesome. Keep going. Move about a 1/4 inch. You know, 4 or 5 mils kind of thing. And then go for a few hundred meters. See what it does. To make it better, make it worse. Yeah, awesome. I like it. Well, come back, clamp it up, put your cover on, whatever, and away you go. Or if not, do a little bit more. But do about a 1/4 inch at a time. And then see what you're doing. 1, am I going the right way? And 2, is it actually making a difference? One thing I'll tell you too, just like Joe said, these guys do an awesome job here at setting up heads. So everything is going to be bang on where it needs to be. Once it moves and loosens up, may need to have a little look. This white indicator is a gauge that we can use for how far I need to pull up and pull down when I'm checking my wing balance. So when your wing is locked, just like it is here, we heard that go. If it doesn't go all the way up like that on its own, that's not the end of the world. Just put your foot on the end of the header and it'll lock in. No big deal. When your wing is locked like this, I want this indicator in line with that bolt head. The reason I say that is because that white line is not self-adjusting. It's adjusted too easy. If you jump up on top here to go clean the window one morning and your boot catches it and pushes it down, okay, and you don't know it, you're in the field, you're looking at it. So that's what you're looking at all day long, and this thing isn't moving. Well, what the heck's going wrong? I'm not really too concerned what the indicator is. That's just a guide. Let the stubble tell you what's going on. Look at the stubble. Are you missing beans or lentils? Nope. Are you pushing dirt? Nope. Nothing's wrong. Maybe that thing got adjusted. So bring it back in line with the bolt. We unlock our wing, and when you go up, lift up. So this comes up the bottom tab right here. Okay, the bottom tab comes about the same height as the top of this plate. And when you go down, so that this little tab comes in line with the bottom. Get her as close as you can. The reason we ask for the cutter bar to be 6-10 inches off the ground, this is a little high for short folk like me because I can't quite reach all the way. I can't get across. If you have to get a stool, I usually carry a stool with me if I'm doing a bunch of these just so I can get up that extra 6 inches just so I can do the reach. That's why. But with that, we also don't want it so low that when you do flex this, that the end or something contacts the ground because now you're not going to get a true reading.